Welcome to Study Loop.
For part A, we can say that here the transformer relationship would be the primary voltage divided by the number of primary turns. This is going to be equaling the secondary voltage divided by the number of secondary turns. We can then say that here the secondary voltage would be equaling the primary voltage multiplied by the number of secondary turns divided by the number of primary turns. So for part A, or rather case A, we have that the secondary voltage for case A, this would be equaling 240 volts multiplied by 50 divided by 100, and this is equaling 120 volts. The secondary voltage for case B would be equaling, again, 240 volts. However, now we have 200 turns divided by, again, 100 turns. And this is equaling 480 volts. And then for the last one, case C, we have the secondary voltage in C. This would be equaling 240 volts times 100 turns divided by 100 turns. And so the secondary voltage for KC would be equaling 240 volts, and we can rank them. So V sub S B is greater than V sub S C, which is greater than V sub S A. This would be our answer for part A. Now for part B, we know that the power in is equaling the voltage multiplied by the current. And so the current is essentially equaling the power in divided by the voltage. And so we're going to solve them for all the cases. We could say current sub S A for case A essentially would be 100 watts divided by the voltage of 120 volts. And this is equaling 0.83 amperes. Secondary voltage for case B, this is again 100 watts divided by 480 volts, and this is giving us 0.208 amperes. And the secondary voltage for case C, 100 watts divided by 240 volts. This is giving us 0.416 amps. And so we can rank them. I sub S A would be greater than I sub S C, which would be greater than I sub S B. And this would be our answer for part B. For part C, it rank the power. And here we know that the power in is going to be equaling the power out for all cases. And so we can say that the power out for case A would be equal to the power out for case B. And this would be equal to the power out for case C. All of them are equaling 100 watts. And so this would be our answer for part C. The solution